The broadcast is now starting. All attendees are in listen-only mode.
Good morning. Welcome to the DBA Fundamentals virtual chapter meeting for July 2014. I'm really looking forward to the presentation today, and if we go by the number of registrants, it looks like this is a highly anticipated meeting. Today's presentation is entitled Table Indexing 101 and is being presented by Denny Cherry. I'll turn things over to Denny in a few minutes, but I want to tell you what's going on here at the DBA Fundamentals virtual chapter, give you a tip or two about the virtual meetings, and introduce our speaker. First, if you have any questions, you can put those in the QA field on your screen, and if you have any technical issues, please raise your hand using the icon that looks like a hand at the right. You can also send me a chat message if you have any technical questions. Denny will have the option of answering questions as he moves through his presentation or at the end. I think Denny's going to try to answer them as he goes through unless there's too many. This session will be recorded, and the web broadcast will be available in about a week on the DBA Fundamentals website on the Archive tab. So if you don't catch the whole presentation, or somehow you get disconnected or you're called away, you're probably at work, things happen, I understand that. You can check back in a week and navigate to the www.fundamentals.sqlpass.org. Upcoming events, of course, the big one is PASS Summit in Seattle, November the 4th through 7th. Be sure and try to go to that if you can. I'm going for my first time this year. I'm really looking forward to it. I'm actually going to try to catch some of the pre-con meetings, which are full-day presentations by very good speakers. With our chapter next month, we're going to have, on August the 5th, we're going to have Argenis Fernandez presenting Rolling Upgrades the Easy Way. We had scheduled this previously, and through several problems, we had to cancel it completely in the month of June. So this will be much anticipated a webinar because we just had problems with an upgrade last night, and I want to catch everything I can from things like this. We're going to have a second presentation in the month of August. That's Erin Stellato. She's presenting a session on reading query plans and what to look for in plans. Erin has a great way of explaining performance in an easy-to-understand way. My name is Steve Cantrell, and I'm the co-founder of the DBA Fundamentals virtual chapter. Feel free anytime to shoot me an email. My contact information is on our website on the About Us tab. Again, our web address, http fundamentals.sqlpass.org. You can also, if you're listening to this, you're probably already a member of PASS, but get your friends and everybody else to join up because free education is just unbelievable. It's just a great environment with the SQL world. Okay, that's all the housekeeping I can think of at the moment. Denny Cherry is the owner and principal consultant for Denny Cherry Associates Consulting and has over a decade of experience working with platforms such as Microsoft SQL Server, Hyper-V, vSphere, and enterprise storage solutions. His firm has a great selection of consultants available for projects and troubleshooting needs, and because he has such a great selection, he can pretty well guarantee he can get you the exact skill set that you need to fit your needs. Sometimes you don't need the very best person in the nation. Sometimes you just need a certain level of help. Sometimes you do need that really good person. Denny's area of expertise includes system architecture, performance tuning, security, replication, and troubleshooting. Denny currently holds several of the Microsoft certifications related to SQL Server for versions 2000 through 2008, including NCM and MVP. He's written dozens of articles on a variety of topics, including SQL Server, VMware, and enterprise storage, and how these various technologies work together. He's one of the premier people out there in how all of this works together because he's so knowledgeable in all these different areas. He's written several books, and just as a way of showing how good his books are, was at a SQL Saturday in Louisville 2 weeks ago, and I was listening to a pretty good security session. I really liked the speaker, and I was thinking to myself, he might be a good person for our DBA Fundamentals group. And then he started talking about how he was referring to, and this is what Denny says in his book, Denny Cherry, and he just kept referring to him. So experts out there refer to Denny Cherry for things. So you're going to get a real treat today. I encourage you to check his website out at dcac.co. That is .co, and follow him on Twitter using @MrDenny. It's now time to turn it over to Denny. And let me unmute him. Take it away.
Thank you very much. Good, well, I think it's afternoon for about half of you. Good morning for those of you on my half of the country. Like you said, my name is Denny Cherry. My contact info you've probably been staring at for the last 5 or 10 minutes or so. So let's go ahead and skip past that. I'm just going to dive straight into the presentation here. You saw most of this, or you heard about most of this as you so kindly introducing me. As mentioned, I am a Microsoft MVP for the SQL Server product, as being a very disgruntled Microsoft Certified Master for SQL Server 2008. A couple of the books that I've worked on are up on the screen there. Securing SQL Server was the one that was mentioned in the intro there. Also worked on one of the 2 SQL Server MVP Deep Dives books, which is that god-awful goldenrod color book that you see there. While the cover is absolutely awful, the content inside the book is absolutely fantastic. It was written by about 60 or so SQL Server MVPs. Each MVP wrote 1 chapter. All the proceeds of that go to, I want to say, Operation Smile. I think that's right. It's either the War Orphans Fund or Operation Smile. I can't remember which charity gets which book. But they do get a check every quarter based on however many copies of that book are sold. None of the MVPs that worked on the book get a dime out of it. We all just wrote it to help get information out and to get some money over to the charity that we picked for that particular book. So let's go ahead and dive into the chapter there. You guys have heard enough about me, and you're probably a little more interested in the content rather than hearing about me. So I've broken the session down into basically 5 kind of high-level bullet points, 4 if you exclude the Q&A section. So we're going to look at the different kind of indexes that are available in Microsoft SQL Server. We're going to talk about some common misconceptions about indexes, some problems people have, and how we can fix those misconceptions. We're going to look at the downside to indexes because this is IT. There's nothing for free. And then we're going to look at some of the advanced index tuning techniques that are available to you that we can use to make indexes perform even better and keep them performing better kind of in the long run. Q&A panel is not cooperating here. I just want to get this open so that I can see it in case there's any questions. There we go. All right, so let's get on with material. So there are 5 kinds of indexes available to us in SQL Server that we're really going to be kind of talking about today. There's actually more than that available in SQL Server, but we're only going to be talking about kind of these first 5. And these are the clustered indexes, the non-clustered indexes, full text indexes, XML indexes, and the column store indexes. Now, you'll notice here that this is an older slide deck. It hasn't really changed all that much since SQL Server 2012 first came out. But there are some new things that were introduced in SQL Server 2012, and that was the semantic search, which we're not going to be talking about because I don't know anything about it. So the only person here saying the slides are not changing. They should be. Let me double check. Now they are. Excellent. Okay. Cool. All right. Delete all these questions. Yes, it can take a minute for GoToWebinar to push the changes out, and sometimes my animations change a little fast. So clustered indexes. So we can have exactly 1 clustered index per table. The reason we can only have 1 clustered index per table, the reason we can't have multiples, is because the clustered index is the full copy of the data. It is the table. So when we first create a table, if we just do create table, whatever, and give it a bunch of columns and execute, we create what's called a heap. So it's an unindexed object. So when that happens, when we go to create a clustered index on that, SQL Server actually reads all the data from that heap and rewrites that data in a new format and then deletes the original copy. And that's why we say that the clustered index is the table, because it actually is. It contains the primary authoritative version of all the data. And that data is sorted within the clustered index by whatever key columns you specify. So those key columns, you can have up to 16 of them. Now, that is not a challenge to you to create a table with 16 indexed columns or 16 key columns. You actually want as few columns as your key columns as possible, and I'll explain more about why later. Now, a side note, if you're going to be using XML indexes on your table, you're going to only be able to have 15 columns as your indexed columns. And the reason for that is because the XML index is going to add an additional hidden column to your clustered key. Now, when you're creating a table in SQL Server, if you right-click on tables and go to New Table, and you get the GUI, the pretty GUI that comes up, and you just fill that out, and you select a primary key in the GUI, and you click Save. By default, that primary key is also going to be your clustering key. Now, that does not have to be the case. There's nothing that says your primary key and your clustering key have to be the same. In fact, a lot of the times they'll be different, especially if your clustering key, especially if your primary key is not a very good clustering key. So one of the things we tell people, or a lot of speakers tell people, is don't use GUIDs as your clustered index. But obviously you're probably going to have a GUID as your primary key if you've got a GUID ID field in your table. So what you end up doing to solve some performance problems and to solve some clustered index problems and some fragmentation problems is you'll make your primary key that GUID column, because that's your uniquely identifying column, but you'll add an additional column to your table, which is an identity column, and then that identity column will then be your clustered key. That way the data is stored in sort order, but your primary key that's used for your referential integrity is that GUID. So that gives you kind of the way to do both at the same time. Now, when you're creating your clustered index, you have to put it on the same file group as the table. If you don't, and it's actually optional to do so, but if you don't put the clustered index in the same file group as the table, it will actually move the data to the new file group. So if I've got a table on primary with 1,000 rows in it, and I do create clustered index on my table, give it whatever key columns I want, on secondary file group name, it will actually move the entire object to that table, or to that new file group. So this is actually really handy because it can give you an easy way of actually moving tables between file groups. Because if you do a rebuild on that clustered index, you can then move it to another file group. So if you need to do a migration of some sort, that's a nice, easy way to do a migration. Because you can move that table nice and easily with just one command to this new location. And if you've got Enterprise Edition of SQL, you can actually do that online as well, because you've got the online index rebuild feature in Enterprise Edition of SQL Server 2005 and up. So your clustered index should be as narrow as possible. So the reason it should be as narrow as possible actually has nothing to do with the performance of the clustered index. It's actually got to do with the non-clustered indexes. So the reason I say that is because the non-clustered indexes contain the value of the clustered key. So when we look at the actual data page of a non-clustered index, and we'll talk a little bit more about the data pages later. So when we look at the actual data that makes up these non-clustered indexes, you'll see all the columns that you've specified, but there's also a hidden column in that non-clustered index. That hidden column, or columns, is going to be the values from the clustered key. And the reason that has to be there is because that's how SQL Server maintains the relationship between the non-clustered index and the clustered index. Now, it makes sense to think about it because SQL Server needs to know what rows are what across all these objects, because indexes are just kind of their own object. So if we go look up rows in a non-clustered index, and we need more columns than the non-clustered index supplies, we need to know what row to go look at them up from, in our clustered index. So to do that, we obviously have to know how to get that data and where that data is. So that's how we know that is by using the clustered index. So because we want to waste as little space as possible in those non-clustered indexes, that's why we want these clustered indexes as narrow as possible. I'm sure we'll talk about that more when we get to non-clustered indexes as well. So clustered indexes, not required. Highly, highly recommended for most tables. All your OLTP tables for all your line of business applications, they should pretty much all have clustered indexes on them. Where they start to become a lot more optional is in your reporting environments, in your data warehouses or your reporting systems, your data marts and stuff like that. The reason we don't necessarily need them there is because that data is all going to be put in by date. It's going to, we're only putting data into a data warehouse one day at a time, and that data all gets put at the bottom of the table. So there's really no point in sorting that data when it's being loaded into the system. So we can just load it all in, and then we're good to go. And also with data warehouses, we're typically only reading off a very small portion of that table. We're going to have all the columns we need covered by our non-clustered index. So there's not much point necessarily in having all those columns specified in our clustered index, because we shouldn't ever be going back to the clustered index, in these data warehousing queries, because they're huge queries and they must be tuned very, very carefully with our non-clustered indexes. So speaking of non-clustered indexes, as we have some questions here. So what do I mean by as narrow as possible? So what I mean by as narrow as possible is as few columns in the clustered index as possible. So throw management's doing up here. Ignore the stuff on the screen for a second here. So when I create a table, and C2 varchar 255, C3, oops, and so we have a table. So what I mean when I say as narrow as possible, we want as little data as possible, width-wise, making up that primary key or that clustered key. So right now, in this table, we've got a 4-byte clustered key. 4 bytes, integer data type. So if I change this to here, we've now got potentially a 257-byte clustering key. Now the reason it's 257 bytes, not 255 bytes, is because we have this thing called overhead we have to deal with. In this case, we have 2 bytes of overhead. The fact that actually no, we only have 256-byte primary key. The reason we have overhead is because it's a variable length field. It's not nullable because it's the primary key, which would be the other piece of overhead we may have to deal with. So we have 1 byte of overhead, which is the fact that we need to manage how wide this column is. So we want to keep this clustered key as narrow as possible. So instead of having this 255-byte wide column, we would want to use one of these integer data types on in the table, so that we can keep that that clustered key is, down to 4 bytes. Because when we copy this table out to the various non-clustered indexes that are going to be in our table, or in our database rather, or that are going to be built on the table in our database, sorry, it's really early in the morning here, we want as little data as possible clogging up all these non-clustered indexes. Because the more data we have to copy from our clustered index to our non-clustered indexes, the more space we're going to end up wasting in all our non-clustered indexes. So that can end up causing problems with performance and with space. So, non-clustered indexes. You can have up to 999 non-clustered indexes per table in SQL Server 2008 and above. Now, this has not changed up through SQL Server 2014. In SQL Server 2005 and below, you can have up to 255 non-clustered indexes. Now, this is not a challenge. Do not create 999 tables or 999 indexes per table. We want as few non-clustered indexes on the table as possible, providing that we still cover all the requirements that our application has. So the reason we can have up to 999 non-clustered indexes is because we need the ability to handle data warehouses, which typically need lots and lots and lots of non-clustered indexes to get the data for the reports, so that we can get the information out of the data warehouse quickly, without causing performance problems. So in 2005, there were a lot of complaints that there were not enough non-clustered indexes. So that's why Microsoft increased that limit up to 999. So when you're creating your non-clustered indexes, your key columns can be up to 16 key columns in that non-clustered index. So these 16 columns that we're putting in as our key columns, these are actually going to be how the data is sorted in the non-clustered index. So we need to think about how the data looks in the table and which columns have the most selectivity when we're building our index. So what I mean by selectivity is what column is going to get us from the entire table to the smallest amount of data possible in a single in a single go. So if we've got an employee table and we want to look for men with the last name of Cherry, building an index on gender and last name is not going to be the most effective index, because probably about half of the values in the gender column are going to say male and the other half are going to say female. So that's not going to be a very selective column for us to use. It would be a much more effective index, much more efficient index, if we flipped those columns around and had the last name column first and then the gender column second. That way, when we're searching through the index, we look for all the rows that have the last name of Cherry, which is probably going to be 1, 2, maybe 3 rows total. And then of that, we can filter those 3 rows down really fast based on whatever the gender column value says. So it's much more efficient that way if we can sort, if we can scan by last name first as opposed to gender. So you really need to know the data a little bit when you are looking through the system to build these indexes as to how these columns should be laid out and in what order they should be laid out as the key columns. Now, remember when we were talking about the clustered indexes a couple minutes ago, I had said we don't want very many columns as key columns in our clustered index because it makes the clustered index very wide, and that causes problems in a non-clustered index. Well, in our non-clustered indexes, we actually want as many key columns as we need. So it is very normal to have non-clustered indexes have 5, 6, 7, 8 columns, however many you need, up to 16, all specified as key columns within the non-clustered index. So that is a great way of of helping performance, is by giving it these really wide indexes so that we can search really easily through all the data. Because if we don't have all the columns we need in our non-clustered index, when we go to actually look for the data, we're going to get back this huge set of results, which SQL Server is then going to need to scan through to find the rows you actually need. Which is why we want to have every column in our where clause as a indexed column in our non-clustered index. We can also add as many non-indexed columns as we want by using the include statement. So the include statement lets us add non-key columns to our index. So a key column should be basically a where clause, or something that's used to limit the number of rows that are being returned. So pretty much where or join clauses. Include columns should be any additional columns that are returned from your select statement. So if we've got an employee table that's last name, first name, employee ID, gender, and we run select first name, last name from employee, where last name equals Cherry, we want to build our index where the key column is last name and the include column is first name, because the first name column is being returned, but it's not being used for filtering. So like I had mentioned, the non-clustered indexes are always going to contain the clustered index values, the values from the columns of the clustered index. If the table does not have a clustered index, so you've built a heap, maybe it's a fact table, maybe it's some other table that's a heap, how do we maintain the relationship between those non-clustered indexes and the base table if there's no clustered values? Well, we actually do that by using what's called the row ID, or the RID. So the row ID is an 8-byte value which tells SQL Server what row within the table the row in the non-clustered index references. And it literally just stores the file ID, the page ID, and then the row number within the page that is being referenced. So when you're creating your non-clustered indexes, you can create them on any file group you want within the database. So as long as it's a data store file group, as opposed to a column store or a hackathon file group, sorry, not a column store, just as long as it's not a hackathon file group, you can store your non-clustered indexes in that file group. They do not need to be stored in the same file group as your base table. It does not help performance to put them in a different file group. It does not hurt performance. Now, we used to spread them out across multiple file groups so that we could get better performance out of our storage. But this was a long time ago, and storage was not as efficient as it is today. So typically, there's not really a need to spread data out across multiple file groups. Now, one of the cool new features about with non-clustered indexes that was introduced in SQL Server 2008 is the filtered non-clustered index. So we can actually use this filtered index to remove rows that we don't need out of our non-clustered index. And this can actually save us a lot of time and a lot of drive space if we can get rid of rows we don't need. So we do this by specifying a where clause when we're building our non-clustered index. So a couple of my clients use these very effectively. So one of them has a rather large table. It's about 3.5 billion rows or so, give or take. And we have an active flag. So what this table stores is survey questions. So the same customers come back time after time and answer the survey. So some of the values are the same across their answers. Things like their address don't change very often, but occasionally do, because occasionally people change their address. Occasionally they move. So there's an active flag that says what the current value is, so that we're not storing duplicate values over and over and over again in this table, because we don't want to store somebody's address 50 times when it's the same value every time. That's kind of silly. So we've got this active flag there. Well, 99% of the queries against this table are only looking for the current values. So they're only looking for the values where the active flag is 1. So what we've done is we've created a set of filtered non-clustered indexes on this table where the filter is where active equals 1, so that whenever the queries are being run, they're always using these much shorter indexes. Because even though the table is about 3.5 billion rows, if we look at the number of rows in the filtered indexes, that's only about 700 million rows. So even though our table is really big at 3.5 billion rows, the only rows that we're actually looking at as far as our working data set is about 700 million. So it's much easier for SQL Server to look through these filtered indexes because they're so much smaller, and it can then search them very efficiently because they're so much smaller. It also saves us a lot of memory because we don't need to load data into memory that we're never going to look at. All those rows that are, that have an active flag of 0, if we load those into memory, we're never going to read them. So we'd be wasting a ton of space in memory. So this way we don't have to even load those into memory because, there's just nothing there. So I have a couple of questions here. Do you still have to drop all non-clustered indexes on the table before moving between file groups? You should not have to. If you do a move of a clustered index from one file group to another, it is going to have to do a lot of writes to all the non-clustered indexes, so it'll probably be faster if you can remove them. But if you're trying to move a huge object online, obviously you're going to need the non-clustered indexes to keep the application running. So that's obviously not going to work. Let's see, if we add up 16 columns in the non-clustered index, go to where clauses, does the order of these columns matter? So the question here is, if we add up to 16 index columns in a non-clustered index to cover where clauses, does the order of these columns matter? It does, yes. So you're going to want to make sure that you've got columns that are the most selective, or as selective as possible, to the left-hand side of the index. So when you're creating the index, you're going to want those, the first columns listed there to be kind of the most selective ones. So in the example I gave earlier, if we're looking for men named the last name of Cherry, you'd want the last name to be the first column in your index, and then the gender to be the second one, because last name is going to be much more selective than gender. Okay. Can we use can we use include columns to accommodate additional where clauses, order by, etc., to get rid of key lookups in these kinds of situations? So yes, sort of. So the include will definitely get rid of key lookups when you've just got columns in your select statement that are not in your index. So that's the exact use case for the include columns. Now, if you've got columns specified in your where clause that are part of your include but are not key columns, yes, SQL Server can still use those for filtering. You'll see an additional filter operation show up in your execution plan. And now that's obviously not going to be very efficient because SQL Server then has to scan all the scan all the rows it gets out of the non-clustered index. So you'll want to make sure that you can at least, at some point move that column from an include to a key column, because you want to get, the most efficient processing possible of that non-clustered index. But yes, SQL Server can do filtering on the columns in the include statement. It just needs to scan because there's no sorting on that data, so it's got to scan all the data to go through it. To include one. Can we include more non-clustered columns in the non-clustered index than in the predicate? Will that index be used? Yes. So if you have more columns in your non-clustered index than in your where clause, yes, SQL Server will still use that index. So same example, index is built on last name and gender. If all we do is select first name, last name from employee where last name equals Cherry, SQL Server will still use the same index. It'll still use that last name comma gender index. So if you've got lots of similar queries that all use the same first set of columns, then yes, they can all use the same non-clustered index. This is where you get a little more into kind of the art of building indexes over the science of building indexes. Is you have to look at all the options and try to figure out which ones are going to be the best ones to keep and kind of which ones would make the most sense to try to get SQL Server to use versus not. So you can get into a little bit of tweaking of stuff and a little bit of trial and error in your development environment to try to see which one of these indexes is going to be the best one to use. Can you explain why it is best to have a clustered index on a table in a non-data warehouse environment? Yeah, so the main reason here is we want the data in some sort of sort order. So if we think about an orders table, all the data is being inserted. We want all the data being sorted in the order that it was created. Now that's probably not the best example because that data is going to be pretty much inserted in order. Yeah, most of these tables are going to be inserted in clustered index sort order. So probably the biggest reason, or a big reason, off the top of my head that I can think of, is typically when we're creating clustered indexes, we're going to use a 4-byte key, which is going to be smaller than our RID. So what that means, it'll be more efficient because it'll take up less space on our non-clustered indexes. Because the RID is 8 bytes, the row ID is 8 bytes. And most tables are actually created with a 4-byte, which would be an integer data type. So we would build that clustered index on that integer data type. The other big reason being when we're doing joins and stuff, we want the data sorted because it needs to be sorted in the same order that SQL Server is looking for it in the secondary table based on the index on that secondary table. So that would be another reason why we want those primary keys, so it doesn't have to sort that table every time you try to run a join against that clustered index. For the include column, what would be better option between non-clustered index on last name, first name, non-clustered index on last name, include first name in terms of consolidating an index to reduce locking by a delete? So just from the perspective of reducing locking for delete operations, those are probably going to be the same because it's going to be looking for the rows to delete out of the non-clustered index based on the clustering key, not the indexed values. So I would say those are going to be probably basically the same. I'd have to test it to be sure, but I'm like 99, 98% sure that I'm right. From a index reusage standpoint, an index on last name, first name is probably going to be better. From a how fast is it to build the index, an index on last name including first name would then be the faster option. But again, you specifically asked about locking for record deletion, so they should be the same. So there are a bunch more questions. I'm probably not going to get to all of these. I will, if I don't get your question answered, I will dump a list of those questions out and answer them in a blog post. There are a ton of them in there, and I want to get through more slides. So, full text indexing. Our clustered and our non-clustered indexes, those are going to be used automatically every time we run a select statement. SQL Server is going to figure out what clustered and non-clustered indexes it should be using automatically. The full text indexes, those are going to be different. Full text indexes are not accessed automatically by select statements. You actually have to specify that you want SQL Server to use the full text index. And you have to tell it a predicate, and you do it by using one of these 4 predicates: contains, contains table, free text, and free text table. So if you've ever programmed and you've ever queried the Windows search service, these use the exact same syntax as the Windows search service. So the full text indexes are really nice because it gives you a more Google style or Bing style search capability within your table. So, instead of needing to write where last name equals, like, CHE% single quote, and search for all the records that match CHE, with a wildcard acronym, you can tell SQL Server, I want to search for all the records where the last name is Cherry, and that's near the first name Denny, and it will actually take that information and it'll actually search against the full text index and find all the records that have the words Denny and Cherry near each other in the text value. So it gives you a really advanced, really nice way of letting users search for data using kind of a more native language search capabilities, a more natural search language capability. Now, one of the things that's really cool about full text search is it doesn't just search on text data. It actually searches on binary data as well. So we can actually take Word docs or Excel documents or PDFs, and you can throw them into a var binary max data type column. You could build a full text index on that, and full text indexing will actually be able to read those document types, those values, those binary values, and actually convert them into text and use that text as part of the full text index. Now, to do this, you have to actually get the DLL for that document type installed on your SQL Server. So the easiest way to do that is just install the application on your server. Odds are sysadmin team probably doesn't want you to do that. You might get away with putting Office on there, but probably not Adobe for PDF. So what you would then need to do is go grab the DLLs from the application and just register those DLLs manually. Then you can build your full text index, and SQL Server will then know how to read all that information, and then you can then search for that information. So this means you can literally load a bunch of PDFs into a SQL Server table and then run a query against those PDFs looking for values stored in those PDF documents. So this is a very powerful technology that can be used very quickly to get some really good information out of the system. It does require a decent understanding of how to actually query for the data, though, to actually get the information that you're looking out of it. So full text indexes are a very natural language search. So again, you're using phrases that you'd be used to using. If you want to look for the phrase apple pie in a document, if you're trying to search through a normal T-SQL search, that would be select whatever from table where where column like percent apple space pie percent. Not a very efficient query to run because you got to scan the entire document, the entire table. looking for that specific phrase, apple pie. But if we ask the full text index to look for apple near pie, it will actually break that apart and seek through the index looking for those values very, very quickly, much, much faster than you're going to be able to get data out by scanning the entire table. Now, I will warn you, and I think I talked about this in a later slide too, when you're deleting rows out of a table that has a full text search on it, it's a lot longer to delete data than it is in SQL Server, in a normal table without a full text index, because there's a lot more deleting that has to be done. So I was actually working for a company years ago that had a full text index on a very large table. So this table was, we'll say 500 million rows, give or take. And we had a full text index on it. So what this table contained was all the URLs that our customers had been browsing to over the last 14 days. So we were a web monitoring company that was monitoring the usage of desktop computers. So with this full text index on the database, when we went to delete data, it would actually take us 36 hours to delete 24 hours worth of data. So obviously this is not very efficient. So we ended up making the business decision to no longer offer that feature as a service, and then we deleted the full text index. Once we deleted the full text index, we could now delete 24 hours worth of data in about 2 hours. So that's how inefficient the full text index was when it came to actually deleting data. So we can put XML documents into our full text index, and it will index them just fine. But keep in mind that if you do that, it is only going to index the values. It is not going to maintain a relationship to how the tags in the XML document are talking about those values. So you're going to lose a lot of context that way. So if you need to index XML documents and all you care about is the values, then a full text index will work just fine. If you need more information about what's in those full text or in those XML documents, then you're actually going to want to look at the XML indexes, and we're going to look at that in a minute. So question here, do you need to delete the full text index before you delete the associated database if you were to delete the database? So it depends on what version of SQL Server you're using. If you're using 2000 or below, yes. If you're using 2005 and above, no, just delete the database and the full text index will go away. The reason for the change is because in 2000 and below, the full text index was actually stored outside the database. In 2005 and above, it is stored, 2008 and above, it is stored inside the database. Have full text indexes existed in older versions of SQL Server, i.e. SQL Server 2005? Yes, full text indexing has been around since at least SQL 2000. It may have been in SQL 7, I don't remember. And I haven't seen a SQL Server 7 instance in a very long time. Do I have any recommendations on how to search full text for multiple languages? Multiple languages starts getting real tough real fast because a full text index only supports one language per index. So you would have to have multiple full text indexes, one for each language, and that starts getting real tricky real fast, and we could probably spend the next 2 hours talking about that. Reed, shoot me an email, and I'll follow up with you on that offline. Yes, Heather. So to clarify, since 2008, the full text index is now stored in the database. Yes, the index is stored inside the database. And you can actually see that when you convert a 2005 or below database into a 2008 database instance, you'll actually see a new file group appear as it converts the old folder name into this really funky, ugly file name, or file group name, and then obviously file name that goes along with that. So that you'll see some really weird object names and file group names, which you can then move the objects out of and then delete those at some point. I see a couple questions. What's my email address? It'll be at the end of the slide deck. It's mrdenny@dcac.co. So XML indexes. So XML indexes are incredibly powerful because they let you index specific nodes of an XML document. Now you can have 249 XML indexes per table. Again, this is not a challenge. You would typically only need 2, maybe 3 per table, unless you've got a lot of XML columns per table. To build XML indexes, you must have a clustered index. This is one of the 2 times clustered indexes are required. The other time is if you're using SQL tables in Azure. That's the other time they're required. So when you're building XML indexes, these are not going to be multi-column indexes. Your XML indexes are built on a single column, and I'll explain more about why in a minute here. So your XML column can have a single primary XML index created on it, and then multiple secondary XML indexes. Because there's 3 different kinds of secondary XML indexes, and I'll explain those more in just a couple of clicks here. So like I said, XML indexes are only created on a single XML column. In 2008 and below, if you create XML indexes, this means you can no longer do online index rebuilds on that object in the Enterprise Edition of SQL Server. This was fixed in SQL Server 2012. So in 2012 Enterprise Edition, if you're using XML indexes, you can do online index rebuilds. So if you've got large tables with an XML index, that's a fantastic reason to upgrade from 2008 R2 or 2008 to 2012 or 2014. So you cannot create an XML index on XML variables or table variables, only on physical tables. And I do not believe you can create them on temp tables either. So the primary XML index is, what it actually does is it creates a hidden table in SQL Server, and that hidden table is going to contain the base table or your table's primary key, and then it's going to contain 12 additional columns of information. Those 12 additional columns are going to allow SQL Server to store all the information about the XML documents in your base table. So it's going to actually shred your XML documents and store them in this hidden node table. The primary XML index is basically the clustered index on this node table. The clustering keys are going to be your base table's clustered index value, or your base table's primary key value, and then the node ID from this table. So the node ID is just one of those 12 columns that's created. XML indexes take a lot of space, between 200 and 500% more space than your base table is going to take. That's because we're shredding all these XML documents and storing them in a relational form. So there's going to be a lot of additional data we're creating because we're not normalizing it, but we're just storing it in a relational table. So our secondary XML indexes, what these actually are, is just non-clustered indexes that we're creating on that hidden node table. So there's 3 kinds of secondary indexes available to us. We can use a path index. We can use a value index. And the path index is going to be created on the path and then the value, whereas the value is backwards of that. It's going to be the value and then the path. And then we have a property index, which is going to be created on the base table's clustered value, the path, and then the value. So those are your three secondary values that are available to you. So why do you want to create multiples? Well, it depends on how your query is written as to which one of these is going to get used. Now, honestly, the easiest way to figure out if you need a path index, a value index, or a property index is in your development environment, just create all three and see which one it uses based on the execution plan, and then only create that one on the large tables in production. That's the fastest, easiest way to figure that out. The performance impact when doing XML queries in SQL Server, like XPath style searching on a table that has XML indexes versus one that doesn't, is huge. I've seen queries that take minutes to run without a XML index. Once we put an XML index on the table, go down to milliseconds. It's that much faster because we're no longer shredding XML documents. And shredding XML documents in SQL Server is an extremely, extremely expensive operation. So if we can pre-do all that shredding, all that expensive stuff, then we can make things run much, much faster. So, some common misconceptions when it comes to indexing. First most common misconception is that indexes do not require maintenance, and they actually do. We need to do maintenance on our indexes for a couple of reasons. We need to resort the data so we can get rid of logical and physical fragmentation so the index performs better. This also helps save space and memory and makes the index more efficient. We also need to do what's called updating statistics. So statistics are what SQL Server uses to build execution plans. Now, SQL Server does its best to maintain statistics in the database, but especially in older versions of SQL Server, it doesn't do the best job in the world. So you have to tell it to update the statistics. Well, one way to do that is to rebuild your indexes. So when you rebuild the indexes, the statistics all get updated automatically. So there's the most current as of when the index was rebuilt. So if we do all that, that'll help the system run much more efficiently. Another misconception that I see occasionally, if I create one index for each column in the where clause, everything will be fine. This is not true. When running your query, 99.99999% of the time, SQL Server is going to use one index per table per query. So if you have one column per index, and you've got 3 columns in your where clause, if you think SQL Server is going to use 3 indexes, you would be wrong. It's going to use one of them, and then it's going to scan through the rest of the data that comes back from that one index, filtering out the other 2 indexes. Or the other 2 where clauses. There are some edge cases where SQL Server will use multiple non-clustered indexes from a single table in a single query, but that is few and far between. The table is physically sorted based on the order of the clustered index. This is no longer true. This was true back in SQL Server 6.5. The table is logically sorted within the pages based on the order of the clustered index. But those pages are not written in sort order on the disk. Pages are written in whatever order they're written in on the disk. So when you go to run a query against SQL Server and you tell it, I want the first row from the table, that is not going to be the page with the lowest page ID necessarily. It could be. It does not have to be. So, the data is going to get stored wherever it can get stored. The reason we don't store the data physically in sort order anymore is because moving data around is just too expensive. If I've got a table that's a terabyte in size and I need to insert a row at the top of the table, I don't want to move a terabyte of data to do a 5-byte insert. That's just silly. So this is why this was all changed back in SQL Server 7. Clustered indexes are required. We talked about this earlier. Oops. So I see a couple of new questions popping up here. Would a rebuild physically resort the data? So yes. So when you do an index rebuild, it actually rereads the data and writes the data to new pages. And it removes the data from the old data pages. So it is physically rewriting the data to the disk. So it's going to redo all the data in all the pages. It's going to free up a bunch of space in the pages. So you get your fill factor back, which we're going to talk about in a couple more slides. And then it's going to write that data to new pages. There was one more here I saw that I really wanted to answer. Do I recommend a rebuild or reorg of indexes after a nightly full backup? It depends. Doesn't really matter what order you do those operations. There's nothing that says you have to do a rebuild or a reorg after you do a backup. It's more important to do a reorg or a rebuild when you need to actually do that maintenance. So you need to look at how fragmented your objects are, and then that'll tell you if you need to actually do maintenance on them or not. There's an index script out there from Ola Hanegren, which is fantastic when it comes to doing index maintenance. And it actually helps you make that decision when you want to do a rebuild or reorg or just do nothing. He's got some recommended percentages there. So I know we're basically out of time, but we're just going to keep on going until somebody tells us to stop. So
keep
downsides to indexes.
Keep going.
Indexes take up space. So this is the downside. We're trading time for storage. Time is very expensive. Storage is relatively cheap. On large, complex databases, it is very normal for indexes to take up more space than the actual table itself, or the actual data itself. This is just normal, because every time we create a non-clustered index, we're creating a duplicate of the values of the columns that are in that index. So the reason we do this is because indexes make queries go fast. Queries running slow causes a lot of time. Time is employee money, is employee salaries. So I've got a great blog post that I wrote a while back. At least I think it's great, but I wrote it, so I'm probably not the most biased or non-biased person to judge it, where I talk about how to actually calculate how much money you're saving your company by adding an index. And basically what you do is you take the amount of time that it takes for the index to run, you figure out how many people use that query per day, multiply that by how many times they run that query per day, multiply that by the average salary for those people, and you figure out how much money you've saved the company per day just by creating one index. And then you can multiply that out by months or years and get some fantastic number, which you can then take to your boss and go, hey, give me a bonus. I just saved us this much money. Indexes are going to slow down your insert, your update, and delete operations. And this is because we're creating these duplicate copies of all these rows, and we need to update all these indexes synchronously before our transaction can be completed. So if we've got a table with one clustered index and 9 non-clustered indexes on it, and we do an insert into that table, we have to insert into 10 objects, the clustered index plus the non-clustered indexes. Sorry, the clustered index plus the 9 non-clustered indexes. So that's 10 writes that have to happen on disk. So that's slower than one write. So the more non-clustered indexes we add, the slower things are going to get. That's why we only want to put non-clustered indexes on that we're actually using. The wrong index can actually be slower than scanning the clustered index. And the reason for this is that you're going to end up doing key lookups back to your clustered index to get the values that you're looking for. So this can just make things even slower than having, no non-clustered index on there. So you want to make sure you've got the right indexes in place to get the performance that you need. So question here, should foreign key columns be indexed even if you do not have cascading updates or deletes? Yes, foreign keys should still be indexed because SQL Server's got to do a lot of checking of values whenever you're making changes to those foreign keys. So you want to make sure that you've got all the appropriate values in there. Because if you do a delete from a parent table, it's got to, even if you don't have cascading deletes on, it's still got to go check to make sure that value is not in use. So if you don't have an index on that foreign key, it's got to scan your table. Obviously not very efficient. That's going to cause a lot of locking and blocking. Question, when the backup is restored, why are all the indexes highly fragmented? So a backup is an exact duplicate of the way the database looked when the backup was taken. So the indexes are going to be just as fragmented as they were when you backed up the database. It does not rebuild the indexes as part of the backup. So the backup is literally an exact copy of the database. So however fragmented your indexes were, that's how fragmented they're going to be within your backup.
Denny, we do need to wrap it up in about 2 minutes. I've never went too much past 10 minutes over, so don't know what's going to happen.
That's usually fine.
Keep going then.
So encrypted data cannot be effectively indexed. So the reason for this is to index the data, we would have to decrypt the data so that we can search it. Because your indexed data is going to hopefully all be salted, which means searching the indexed values is going to be useless, or the encrypted values is going to be useless. So we would need to decrypt the data and then search it. So that obviously is not going to work very well. And hopefully we'll be done in about 5 minutes. So some advanced index tuning techniques. So the first one is fill factor. So fill factor, if you've ever built an index, you've probably seen the fill factor setting before. And fill factor tells you, it tells SQL Server, doesn't tell you anything. You tell SQL Server how much white space to leave on each 8K data page when building or rebuilding the index. So this is how we solve our fragmentation problem. So if we build an index without any free space, and we go to insert a row, we need to do page splits, and then we get fragmentation, and all sorts of bad stuff then starts to happen, because we need to deal with all this fragmentation that's now happening. So we solve that by leaving white space in our data pages. Now, this is both good and bad. So the good is it solves our fragmentation problem. The bad part is we now have to waste space in memory and on disk. And that means because we're wasting space on disk and in memory, that means when we go to read the data off the disk, we're now going to have to read more data off disks, or off the disk. And that's because we need to get the data up. And there's this white space sitting there that we have to deal with. So it's both good and bad. So you need to balance that out when you're setting your fill factor. So you want to set it high enough that you don't need to, fill factor is an annoying setting because it's backwards. It's a percentage, and it's actually the percentage of data that's going to be on the page. So 90% fill factor means 10% free space. So the lower you set it, the more white space we leave. So get that out there. So you need to balance it out between too much white space and not enough white space, because you want enough white space on the page that you can not have to rebuild your indexes very often, but not so much white space that you're wasting a ton of space. And you also need to pay attention to what indexes you're putting this on. So if you're putting building an index on an ascending key column, like an identity column, for example, then you don't want any fill factor because you're never going to insert old records, or you're probably never going to insert old records. When you have a non-ascending key column, so if you're building a column on, say, last name, then you want some white space. You want to set it to maybe 70%, 80%. That'll give you a little bit of white space. If you're building a non-clustered, or any index really, on a GUID, on a unique identifier data type, then you probably want about 50% white space, because there's going to be a lot of fragmentation happening, because GUIDs are not going to be in order. So I have a question here. Doesn't that depend on where you set it from, i.e. SSMS or T-SQL? No. So it doesn't matter if you set it in Management Studio or T-SQL. Fill factor works the same way. Because all Management Studio does, if you aren't aware, is it just runs T-SQL. It doesn't do anything else. It doesn't have some magic interface to the database. All Management Studio does is run T-SQL against the database engine. So there's a default fill factor setting for the server, and all that does is tell SQL Server when you build an index, use this fill factor by default, which is 0. So in other words, highly fragmented, or easily becomes fragmented is probably a better phrasing. So you're going to want to adjust that when you actually build your other non-clustered indexes. But yeah, it doesn't matter if you use it, how you set fill factor, either through T-SQL or Management Studio, it's doing the exact same thing. And it does require a rebuild to change fill factor, which I think is really annoying. Now another setting is padding. So padding is an interesting setting. So the fill factor setting only applies to the data in the index. It does not affect the navigation portion of the index, or the B tree. The padding flag, which is a binary flag, on or off, tells SQL Server to apply the fill factor to the rest of the B tree, to the navigation portion of the index. So if you set that on, you'll have white space in your navigation, in your B tree. So I always recommend having padding turned off for identity or indexes built on date time, because those are going to be in sort order already, and we're not going to be doing any page splitting, so we're fine. For other indexes built on names and stuff like that, I recommend having padding turned on. We have online index rebuilds. So online index rebuilds give us the ability to rebuild our indexes without taking the application down, because we don't take exclusive locks on the table with online rebuilds. So this was introduced in 2005, and it is an Enterprise Edition feature. So it is only available in Enterprise Edition. Can I repeat my recommendation for padding? So padding should be turned off for indexes that are ascending values, identity or sequences, and date time, assuming that you're not inserting old values. If all you're doing is adding incrementally higher values to the bottom of the table, have padding turned off. Indexes built on things like names, dates, when you're indexing by something like birthday, you're going to be inserting values all over the place. Then it should be turned on, because that'll minimize the page splits in your B tree. So, and then the last advanced index tuning technique is data compression. So data compression is actually going to allow us to compress the data as we store it in the table. So this lets us save space by compressing the data. Now this is going to cost us CPU, but most servers are space constrained and not CPU constrained these days. So we want to save space by burning CPU time. Most of the time, this is fine. There are obviously edge cases where compressing data is going to make things slower because we do have to decompress that data to actually use it. But most of the time, it's going to be just fine to compress it, leave that data compressed. So I'm going to talk about column store really, really fast because we're already 12 minutes over. So column store is a new way of handling data in SQL Server. It's a new approach to storing data. We're storing data in columns, not in rows. And each column is then stored separately on the disk, and it's then processed independently, and is all highly compressed using the Vertipack compression engine, which has a different name as well, and I don't remember the other name for Vertipack compression off the top of my head right now. So this is our first B-tree-less index. So this does not have the same B-tree and same navigation that all our other indexes have. So we actually have to scan a column store index every single time we want to use it. So that may seem like it's a bad thing, but it's actually a pretty good thing most of the time. This is going to be really good for running reports. It's not going to be good for singleton lookups like online OLTP applications. Column store is specifically built for data warehouses. So using these techniques to build indexes, how do you actually build an index? So, don't, hang on, my mouse is freaking out on me, sorry. There we go. So to build an index, we use one basic statement to build pretty much every kind of index. So the basic syntax is create index, give it a name, on, give the object the table, on the specified columns that you're including in the index, include whatever columns you want to include, so from your select statement. If we're going to filter, we're going to filter, add that where clause there. We can then specify our advanced tuning options, where fill factor equals whatever, pad index on or off, online equals on or off, data compression equals row or page, and there's a few other options there as well that are available to you. So if we want to build a clustered index, right here where the laser pointer is, we simply insert the word clustered. If we want to create a unique index, we do create unique index. If we want to do a column store index, create clustered column store index on whatever table. So it's a very simple create statement. You just throw a couple of extra keywords in there and you get various different kinds of indexes. So question about doing an index rebuild. If you use 0 as the fill factor setting in the sys.indexes table, are you faster or slower than re-indexing with a set fill factor such as 80 or 100? So with fill factor, first thing to keep in mind, 0 equals 100. 0 and 100 mean the same thing. So the lower the fill factor, the longer it's going to take to write the index to disk because you're giving more and more white space on the file. More and more white space on disk is going to be saved, so it's going to take longer to write because the index is going to take up more and more space. So keep that in mind as you're setting that fill factor setting. So how do you know how big your indexes are? sys.dm_db_index_physical_stats. So that's going to tell you how large the indexes are. So that's a dynamic management function. It takes 5 parameters. Those are in order: database ID, object ID, index ID, partition number, and then the mode you want to look at. Null is limited, or sampled, or detailed. Never run this with 4 nulls and then detailed, because that will query it'll tell SQL Server, read every page off the disk. You never want to do that in production, not if you like your job. Always give it at least a database ID and an object ID, unless you are only doing limited. So this is going to go look at the actual index and figure out how big it is. Limited and sampled are going to be estimates. Limited is simply looking at the root page and doing some calculations. Sampled is looking at the B tree, the entire B tree, and then calculating based on that how big it is. Detailed is looking at every single page and giving you an exact amount. So question here, how big do I mean how fragmented? No, I mean how big. This is telling you how big the index is, the actual size taken on disk. If you need to know what indexes are being used, don't bother trying to read the T-SQL code here. You're never going to do it, not on your monitor, not in a little window. Go grab the slide deck. It'll be available on my website. Or go look at SQLfool.com. That's where I stole this code from originally. Written by Michelle Uford. It will actually tell you which indexes are being used and which indexes are not being used. And it's simply going to tell you that based on how many scans, seeks, lookups, and updates are being done to each index. So if an index is being maintained, excuse me, that means it's being updated. But if it's being updated and it's not being seeked, scanned, or looked up against, then there's no point in having it. We're maintaining an index for no reason at that point. So we got a question here. Does the physical stats DMF cause any locking or blocking? It should not cause any locking or blocking. It will thrash I/O, so you could see I/O waits for queries because it's not a lower priority command than anything else. So it will cause performance slowdowns if you run a detailed scan of all your objects. So I have some homework for everybody. If you go to that URL, dcac.co/res/table-indexing-net, there is a bunch of additional reading material on all these various topics. And I believe the slide deck is there. It might be, it might not be. I will get a copy of the slide deck over to the virtual chapter so they can get that posted up there with the recording. So you can grab this URL from there, or you can just grab it here right now. I'll leave it up there for another second. And that will get you, more information about all these various topics that I've covered over the course of the last hour and 20 minutes that I've been talking about this presentation. So normally we do Q&A, but we've already kind of done that. I know there's a bunch of questions I did not get answered. We will get a dump of these questions so that I can get these answered, at least on my blog. If anybody has any questions we don't get answered, we didn't get answered, you need answers today or in the next day or so, shoot me an email, mrdenny@dcac.co. I'm more than happy to answer questions. I'll try to get them answered as quick as I can. I am fairly well booked up for this week, and then I've got 3 weeks of travel coming up, but I will get you answers as fast as I can get them typed out. I thank you all very much for coming. I know it's been a little longer session than expected, but thank you all very much for attending today. Hope you enjoyed the presentation. Thank you very much to the guys running the virtual chapter. I know you've had a hellish morning with your production problems. But thank you all very much for coming, and have a great rest of your day. And hopefully I will see everybody at the PASS Summit.
Thanks, Denny. I mean, this was fantastic. There's a lot of stuff in there that I want to go back and look at, and because you were just explaining it so well. Mark Swafford and I were sitting here talking during some of the stuff, and technically you're way up there, but you can get in and you can explain stuff like this, like you're sitting down beside somebody at their desk and you're their best buddy. It's just so great the way you explain things. Let me get back to finishing up. We'll have the recording out there in less than a week, and as Denny said, you can get the slide decks off of his website, and I'm going to dump off all of these questions and send to him, and anything that he's missed he should be able to answer. We are giving away an Amazon gift card that goes to Ying Lu We'll be getting that $25 gift card to you within 3 or 4 days. Give me a tweet at SQL Select if you haven't got anything pretty soon, and we'll take care of it. Again, next month we'll have Rolling Upgrades Made Easy on August the 5th, and on August the 19th we'll have Aaron Stellato going over query plans. And be sure and check our site, because we're trying to go to 2 sessions a month. Not every time, but we're working into that, and so things will be changing pretty quickly. Thank you. Thanks again, Denny.
No problem. Thanks for having me.